Welcome to ReneEnergy.com on YouTube, the hub for all things renewable energy and sustainability. Our channel is dedicated to bringing you the latest innovations and insights in green energy, including cutting-edge developments like green hydrogen. Whether you're a sustainability veteran or just beginning your journey, we have something for everyone. Join us on this channel to explore inspiring projects for a sustainable tomorrow. We bring you the latest in renewable energy, sustainability, and cutting-edge technologies. And don't forget, for more in-depth information and resources, visit our website and subscribe to our newsletter for the latest updates and exclusive content. Wind turbines, towering embodiments of human ingenuity, have become symbols of our commitment to renewable energy. These structures, elegantly dotting landscapes and seascapes, convert the kinetic energy of wind into electricity, a process crucial in our endeavor to harness sustainable energy sources. However, their efficiency and longevity are intrinsically linked to one critical factor: maintenance. Understanding the importance of maintenance in wind turbine operations is essential. These colossal machines, often located in remote or challenging environments, are subject to constant wear and tear. Factors like wind speed variability, weather conditions, and mechanical stresses continuously challenge their operational integrity. Consequently, routine and effective maintenance isn't just a requirement, it's the linchpin of optimal performance and longevity. The maintenance of wind turbines is a complex task. Given their size and location, conducting regular checks and repairs is not only costly but also logistically challenging. Traditionally, maintenance teams rely on scheduled inspections and reactive measures, addressing issues as they arise. However, this approach has significant downsides, including unplanned downtimes and the risk of major breakdowns, which can be costly and detrimental to energy production. Enter the modern approach to wind turbine maintenance, a paradigm shift from reactive to proactive strategies. This change is driven by advancements in technology, particularly in the fields of data analytics and artificial intelligence. Today, the focus is on predicting and preventing failures before they occur, a method known as predictive maintenance. This approach leverages the power of data and AI to transform maintenance from a challenge into an opportunity for optimization. In this video, we'll explore the intricacies of wind turbine data, understand how AI and machine learning algorithms interpret this data, and delve into the world of predictive maintenance. We'll see how these technologies not only enhance the efficiency of maintenance tasks but also extend the life of these renewable energy giants, ensuring they continue to provide clean energy effectively and reliably. Understanding wind turbine data. At the core of wind turbine efficiency and longevity is a foundational element: data. These modern-day giants are not just mechanical wonders but also data-producing powerhouses. Each turbine is fitted with an array of sensors that work relentlessly, gathering crucial operational information. This data, often underestimated, forms the backbone of wind turbine health monitoring. The types of data collected are diverse and plentiful. Sensors track wind speed, turbine rotation, temperature, vibrations, and more. Each data point provides a glimpse into the turbine's health and performance. For instance, vibration sensors detect imbalances in the rotor blades, while temperature gauges monitor the heat in critical components like gearboxes and generators. But the sheer volume of data can be overwhelming. A single turbine can generate gigabytes of data in just one day. This data is not just numeric values, it's a continuous narrative of the turbine's operational story, detailing every subtle change and trend. The real challenge lies in making sense of this vast, complex dataset. It's akin to finding patterns in a vast ocean of information. To understand this data, one needs to dive into the intricacies of turbine operation. Each component of the turbine, from blades to bearings, has its own tale to tell. For instance, a gradual increase in vibration levels might indicate wear and tear in bearings, while fluctuations in power output could signal aerodynamic imbalances in the blades. Detecting these subtle cues early can be the difference between a simple maintenance fix and a costly, full-scale repair. However, the human capacity to process and analyze this data is limited. This is where artificial intelligence and machine learning come into play. These technologies are adept at handling large volumes of data, identifying patterns and anomalies that might not be immediately apparent. They can process this information faster and more accurately than any human, turning raw data into actionable insights. In the next section, we will explore how machine learning algorithms take this data and use it to predict potential failures, transforming maintenance from a reactive to a proactive practice. The role of machine learning algorithms in data analysis. The leap from raw data to actionable insights in wind turbine maintenance is a journey navigated by the sophisticated compass of machine learning, ML, algorithms. These algorithms represent the pinnacle of data analysis in the age of artificial intelligence, turning the tide in how we approach wind turbine maintenance. Machine learning, a subset of AI, operates by identifying patterns within data. When applied to wind turbines, ML algorithms analyze the continuous stream of data from sensors, learning from historical trends and operational benchmarks. This analysis is not superficial, it dives deep, understanding the nuances of every vibration, temperature change, and acoustic signal. Consider the complexity of a wind turbine. Each has thousands of parts, each part producing its own data signature. Machine learning algorithms dissect this complexity, differentiating between normal operational data and signs of potential issues. For instance, an algorithm can discern the typical vibrational pattern of a healthy turbine from the irregular vibrations indicative of a misalignment or bearing failure. The true power of these algorithms lies in their ability to learn and adapt. Unlike static analytical models, ML algorithms evolve. They grow smarter with each data point, refining their predictive accuracy over time. This learning process is crucial for predictive maintenance. It's not just about identifying a problem but foreseeing it before it manifests. But how does this work in practice? Machine learning models are trained using vast datasets of turbine operations, including instances of failures and malfunctions. By analyzing this data, the models learn to recognize the precursors to such events. When applied in real time, they monitor current data against these learned patterns, alerting maintenance teams to anomalies that suggest impending failures. The benefits of employing ML in wind turbine maintenance are profound. Predictions made by these algorithms allow for timely interventions, preventing costly downtimes and extending the lifespan of turbine components. Moreover, as these algorithms improve, their predictions become increasingly precise, enabling more efficient maintenance schedules and resource allocation. In the next section, we will delve into the proactive approach of predictive maintenance, exploring how it uses the insights provided by machine learning to revolutionize wind turbine upkeep. Predictive maintenance, a proactive approach. Predictive maintenance heralds a new era in wind turbine care, a shift from the traditional reactive methods to a proactive, data-driven strategy. At its core, predictive maintenance leverages the insights gleaned from machine learning analysis to anticipate and address potential issues before they escalate into costly failures. The traditional approach to turbine maintenance often follows a set schedule or reacts to failures after they occur. This method, while straightforward, can lead to inefficiencies. Scheduled maintenance might occur when it's not needed, leading to unnecessary downtime, and reactive maintenance can be more expensive and time-consuming, dealing with failures after they've caused damage. Predictive maintenance turns this paradigm on its head. By continuously analyzing data from turbines, machine learning algorithms can identify signs of wear or malfunction long before they become critical. This advanced warning system allows maintenance teams to act preemptively, scheduling repairs at the most opportune times and avoiding unplanned outages. The advantages of this approach are manifold. Firstly, it significantly reduces downtime. By addressing issues before they lead to failure, turbines spend more time operational and less in repair. This increased uptime directly translates to higher energy production and, consequently, greater revenue. Secondly, predictive maintenance extends the lifespan of turbine components. Regular, timely maintenance prevents the excessive wear and tear that can result from operating with faulty parts. This not only saves on the cost of replacements but also enhances the overall efficiency of the turbine. Furthermore, predictive maintenance allows for better resource allocation. Maintenance teams can plan their work more effectively, ensuring that they're addressing the most pressing issues. This efficient use of resources leads to cost savings and a more streamlined maintenance process. The implementation of predictive maintenance is not without its challenges. It requires a robust infrastructure for data collection and analysis, as well as skilled personnel capable of interpreting the insights provided by machine learning algorithms. However, the benefits far outweigh these initial hurdles, offering a smarter, more efficient way to maintain our wind energy assets. In the final section, we will explore the future implications of AI and machine learning in wind turbine maintenance, envisioning the advancements and possibilities that lie ahead in this dynamic field. The future of wind turbine maintenance with AI. As we stand on the brink of a new dawn in renewable energy, the future of wind turbine maintenance shaped by AI and machine learning is not just promising, it's revolutionary. This final section explores the potential advancements and broader implications of these technologies in the realm of wind energy. The evolution of AI in wind turbine maintenance is expected to go beyond just predictive analytics. The integration of advanced technologies such as IoT, Internet of Things, big data, and edge computing with AI algorithms will further enhance the capabilities of predictive maintenance systems. In the future, real-time data analysis will become more streamlined and precise, enabling even more accurate predictions and efficient maintenance strategies. One exciting prospect is the development of self-diagnosing turbines. Equipped with AI, these turbines could continuously monitor their own health, diagnose potential issues, and even initiate maintenance requests. This level of automation could significantly reduce human intervention, making maintenance more efficient and reducing the risk of human error. The future also holds potential for more personalized maintenance schedules. AI systems could tailor maintenance plans for individual turbines based on their specific operational history and environmental conditions. This customized approach would optimize maintenance efforts, ensuring that each turbine receives care precisely when it needs it. Advancements in AI will also likely lead to more sustainable maintenance practices. By optimizing repair and maintenance schedules, we can reduce the environmental impact associated with turbine upkeep, such as transportation and the use of materials and resources. This aligns perfectly with the overarching goal of renewable energy, sustainability. However, the journey towards this AI-driven future will require continuous innovation, investment, and collaboration among technologists, engineers, and the renewable energy community. Challenges such as data security, algorithm accuracy, and the integration of AI systems into existing infrastructure will need to be addressed. In conclusion, the fusion of AI and machine learning with wind turbine maintenance is set to transform the renewable energy landscape. It promises not just enhanced efficiency and reduced costs but also a significant leap forward in our sustainable energy goals. As these technologies evolve, they will play a pivotal role in ensuring that wind turbines continue to be reliable, efficient sources of renewable energy for generations to come. Thanks for tuning into the ReneEnergy.com YouTube channel. We trust you found this episode enlightening and motivating. There's a world of innovation and opportunity in sustainable energy, and we're delighted to share this journey with you. Stay in the loop with the latest on renewable energy and sustainability by visiting our website and subscribing to our newsletter. Your support is immensely appreciated, it's truly invaluable to us. Don't miss our next video on new trends in renewable energy. Follow us on social media for the latest updates. Enjoyed the video? Like, subscribe, and share for more green insights. Thanks for watching.